Started here, and as I mentioned, we're being recorded, and Teresa Walters is here and all set up, and so please be careful of the cords. As far as your movement, I think we've got two cameras going. The screen looks like it's high enough you won't be impeding the view, but I guess trying to stay out of the center of that. As far as your microphone, we've got a center mic that's kind of fanning out, so I think you'll be good with your sound. I've got a clicker working, so everybody's, I think, used this before on the first presentation, right, forward, backwards. There's a blackout, don't hit it. If you do, hit it again. And there is a little pointer here if you want to make an emphasis point on it. So that's running. Everybody's PowerPoint is up and running, so you just have to find it. You don't have to double click it and get it running again, except the Prexy one, wherever you guys are sitting. You have to do that. So, all right. As far as timing, I'm going to start my stopwatch, and I will stand at 9 minutes. You have 10 minutes to do it. If you're almost done at 10 minutes, I'll be a little lenient, right? But we don't want you droning on and on into 15 minutes. That's not going to happen. All of the mentors have sheets that they're going to be taking notes on about different things. You guys have all done presentations multiple times in the past. For some of you, this is the last final of your college career. Am I right? And so this should be the very best presentation of your college career. So I'm looking forward to seeing that. No pressure, but that's what we're looking forward to. Are you guys good to go?
Good to go.
All right, let me sit down and get my stopwatch rolling here.
I'm Greg, and we're working on Burgess and Niple.
I'm Doug. Steve Martino.
So we were working on a site located at 4350 Pleasant Valley Road in Fairfax County. You can see it's located up near DC in the northern part of Virginia. It's separated by the Loudoun County and Fairfax County county line, and we focused on not developing in that Loudoun County site to make sure that we didn't cross over any regulations between the counties or zoning ordinances. Down here, this is the comp plan land use map. We focused on making sure that we stuck with the comp plan and made sure that we were meeting the regulations and things they focused on in the comp plan. The zoning ordinance, the site actually had to be rezoned and had to receive a special use permit. It was zoned residential conservation, which in Fairfax County, they look to preserve the ecology, and it's roughly 5 to 10 acre lots. The special use permit was given because we're developing a church, and it's a roughly 33,000 square feet, and that falls under the special use permit as a place of worship. It also is going to have a nursery and a future development of a playground. We did our feasibility analysis. We used our wetlands delineation. There are no wetlands located on site. We also used our web soil survey. There are no protected farmland soils also located on site. But we do have a 100-year floodplain on site, which we had to make sure that we kept undeveloped to ensure the safety of the development and the preservation of the ecology. The existing site conditions, we do have existing water across the street, sewer across the street, and there is a connection to the public stormwater down at the northeast corner there. We also have an environmental quality corridor that is to remain perpetually undisturbed. However, you can put passive BMPs as well as unpaved trails and stuff through the EQC. We also have a resource protection area, which in this location is to preserve, it's in the Occoquan Reservoir watershed. So it's to preserve the water quality and stormwater runoff. So we start with our grading. We had to focus on the parking lot as that was going to be our biggest part of the development. The site is located on a ridge, so we focused on placing the parking lot in the areas of low slopes to ensure that it would be less earthwork, as well as focusing on using that ridge to maintain our runoff for stormwater and to ensure that we were going to minimize the cost for earthwork, since that is roughly 1/3 of our cost. The building plot was set at 268 feet. We figured that 268 feet for our building plot elevation would best meet our stormwater runoff and grading plan to minimize costs for the parking lot. We also have our step off of 1 foot for the first 10 feet to ensure that no water is going to be running towards the building. Our ADA access is located right here, and it goes to the west entrance of the building. It has met all ADA requirements and regulations as inch per foot. And it consists of 6 ADA accessible parking spots as well as 1 van accessible parking spot. And we're using a retention pond on site for our stormwater, and just moving that up to, we initially had it lower than that. Once we moved it up to 264, we actually reduced our grading cost by $100,000. So it was pretty interesting to see how such a small thing can save your cost.
All right, so I'm here to talk to you about the wet utilities on site. As Greg was talking about, there was a water main connection through a 2-inch blow-off valve located right across from Blue Spring Road. That was connected and run with a 6-inch ductile iron pipe all the way to the building. One of the fire code regulations is that a fire hydrant be within 50 feet of the building, so we placed that right across our egress access way, and that consisted of the fire hydrant itself and a 6-inch valve. Right before we got to the building, as you can see, there's a 3-inch valve and a 1.5-inch water meter before the water is actually fed to the building. Now, another fire regulation was that you need a fire line also going in a separate way. So we have that coming off right there, as you can see from the picture. The connection was actually made at 253 feet in elevation at that point, and made the connection with the building at 259. Now, the other wet utility is sanitary sewer. This was a little more complicated than the simple lateral line that was connected with water. It was an 8-inch PVC. And as you can see, we connected at 250 to this manhole that connected in with city water, or the city sewage. And we had to encase that with a 24-inch corrugated metal pipe. And that was in order to provide structural stability as it crossed the right-of-way right here, with the increased pressure of the road and vehicles, or vehicular traffic. Once we got out, there was a clean out placed every 50 feet as per regulation. It crossed the stormwater pipe right here, and all clearances and covers were to code, and it ties into the building right in the very back. And as I said, again, these are clean outs, not manholes, every 50 feet. We weren't allowed to put one in the access way, so the 50 feet regulation that I was talking about was just for the first kind of stretch of the pipe. Now next, I'm going to talk to you about the stormwater management system we put in place, which comprised of two main pipelines, both running from west to east, one on the northern border of the site, the other on the southern border. It consisted of 15-inch reinforced concrete pipes, inlets, grates on the two grates located here on the ground for the 2 islands, and a retention pond that Greg was talking to you about. And as you can see, the 2 outlets empty into the retention pond at an elevation of 254 feet. And because it is a retention pond, we wanted to keep a few feet of water in there at all times. So the outlet structure, the drainage structure right here, which leads to the 36-inch reinforced concrete pipe that leads to the sewer, or to the city's stormwater management system, is located at 254 feet above elevation. So that's going to keep a little bit of water in there for us. Other than that, you can see it's not the most complex system, but it provides the means to keep the peak discharge of our site adequate with the pre-development number. So it was a success.
For erosion and sediment control, we deployed basic methods including temporary stone entrance, silt fence, diversion dikes, sediment basin, as well as a retention pond. For the flow path, as you can see right here, directs this way, and we have constructed a diversion dike right here, which is called a right-of-way diversion dike, composed mainly of soil, but where it crosses our construction entrance right here, it's going to be made of stone and we're going to have an entrance right here that's also going to be made of stone for easier crossing. As you can see, we have a diversion dike down here to the south. Both are intended to route water over here to our sediment basin. A sediment basin was chosen over a sediment trap because of the increased area over here. This is a large construction area, and a sediment basin would be able to handle more water than a sediment trap would. Some of the methods used for the erosion sediment control phase 2 for our inlet structures, we have right here, we're going to be, for our curb inlet structures, we're going to be using wire mesh and stone. And then for our yard drain inlets, we're going to be using a fabric drop. Over here, you can see we've converted to our retention pond, which has outlet structure protection, which is composed of riprap, which will help reduce the velocity of the water going into the pond. We have standard seating right here, and that will also be right here in between the building and the parking lot, as well as the parking lot and the diversion dike. For the cost estimate, we estimated it to be about $1.8 million. We also came up with some cost reductions. Earthwork, we realized we could reduce it $100,000. We could do this simply by reducing the earthwork by 1 foot, by a half a foot. We came up with the second method, which would be removal of the islands, which would save about $10,000. We believe that this is an aesthetically pleasing and optimized plan, and that concludes our presentation.
Questions? Can't take it easy on the first group.
The layout of the parking field,
Yes.
what's going on in the middle of those?
The islands.
Yes.
They wanted to focus a lot on stormwater quality and reduce runoff, so we decided to put vegetated islands to provide an aesthetically pleasing area as well as reduce some of the impervious area within the parking lot.